Hello and welcome. This is an introduction into RAYN Vision System Analytics. I'm Alex and I will give you a short tour through one analysis, an example analysis with RAYN Vision System Analytics. We are currently running version 1.1, build 7. If you have an older version, there might be a few features that are not available in your version, so please upgrade. But it's also possible that we already released a newer version. But I think you should be fine, and image analysis should not change in the future too much. So as you can see, I already played around with this, and I recommend you to use with blank settings. To do so is press on experiment and new experiment. I will explain all the detailed functions in another video. Right now it will be only about analyzing your set of images. Be sure to press no if you don't want to save the experiment settings. And this will basically remove all settings, all previous settings, and we will start from the very beginning, from a blank experiment. The order of the submenus right here is intentional. We'll start at the top and we'll go through all of them until the bottom. And then we can run the analysis. So first step is the image source. There are 3 image sources available. It's a single image, it's a folder with images where all the images in the folder are analyzed. It's also possible to connect to the camera directly and download images or analyze them online. I will explain all the different modes in more detail in a second video. We will just use the folder mode for this example analysis. I press on browse, and because I previously already selected this folder, it will already open the last folder I opened. It's on desktop, image sets, and then I have a folder called cannabis, which contains images. You won't see the images right here, so please make sure you selected the correct folder. It's also possible to select a different folder for the output files, but I recommend you to use the default one. Next step are the image options. There are 4 options available, setting the correction for the lens distortion. If you have the latest version of the RAYN Vision system, then use the 60-degree lens. There's also an option for 120 degree, but the current version of the camera does not contain the 120 degree lens anymore, and it's also possible to set it to no compensation. I will check the box for normalize. What this does is it will subtract the dark reference image from all the other images from the other wavelength bands, and by this basically normalize the whole multispectral image. It's also possible to correct for different light intensities if there are differences in the distribution. That's not necessary for the latest versions of the RAYN Vision System camera because it has this correction inbuilt. It's also possible to rotate the image and then crop it as well. I'm not introducing this option right now because it's not needed. Next step, regions. The first thing you do once you want to select a region of interest or regions of interest is selecting sample images. If you are in folder mode, it's probably easiest to just pick one image from the folder. I'm using the first image in my time series, and it will automatically load the last image as well. You can also increase the window size and then also the size of the sample images will increase. Now let's talk a little bit more about regions of interest and the selection modes. I will go more into detail about the different options in a separate video. Right now I just want to introduce to you the different placement modes. There is a matrix mode. If you have multiple plants, and you can change the rows and columns and also the radius as well as the shape. But what we will do is we will go for the individual mode. It will actually leave all the rows you created in matrix mode, but you can always clear them with the Clear ROY button. I will simply go with a single ROY and increase the radius a little bit. It's always good to have the first and the last image because sometimes your plants move a little bit. And as you can see, this is mirrored. So you can either move the ROY on the left or on the right side and try to place it in a way so it basically covers or touches the plant you want to analyze. We are using the detection mode partial, so everything that partially overlaps with the region of interest will be analyzed. There are also other modes like cut to and largest, and you can find more information about them in the user manual. Right, next step is setting an analysis script. Currently there's only one analysis script available, but you can add your own. It's basically a Python script, and there are instructions online how to create your own analysis script. And you can just add it by drag and dropping it into the scripts folders in the application folder. Mask script. It's possible to have different mask scripts with one analysis script. Masking is basically the first step to differentiate the background from the plant. And I recommend you to use the default script, but there are also other mask scripts available. You can use either indices, like reflection indices, to mask your plant or the background. And you can also use wavelength bands. And there are also options to combine two indices or two wavelength bands. So the default for the base script currently is a single wavelength band. And I will just leave it at the default. I recommend this to you as well. But if you want to choose something else and play around with it, I can introduce some of the options of the other mask scripts in another video. You can open the mask dialog by pressing on masking, and it will automatically load the two sample images you loaded previously. Again, you can increase their size by increasing the size of the window. And as I said, the default script uses wavelength bands for segmentation, for masking. And we will simply choose a wavelength band which is known to be quite predominant in plants, for example, far red, the 740 nanometers. And then we can simply play around with the threshold and decrease it a little bit. And here you can see that we can see our plants. So the goal is actually that we basically have all white where the plant is. This does not matter too much to us because we can also highlight the ROY right here because the ROY does not touch this part, for example, this artifact or this right here. This is a reflection of this tape. And this does not matter too much to us. Right here we have one oddity. This plant, this leaf of the plant is not entirely visible. So that's why I would still decrease and further decrease the threshold. Right. So this is a little bit too much. You can also simply press or left click to the right or the left, and it will automatically go the next biggest step. And I think actually this should be fine. Right, so it basically catches everything we need. I don't want to go into details right now. We can make another video about how to set your masks perfectly. Dilated pixels basically increases the pixel size a little bit. It dilates the pixels. It does what it says. And sometimes it's useful to connect disconnected plant parts. Right now, it does not matter too much. I will leave it off. Good. So this ROY overlay shows you where your ROYs are. And right now, what's visible is that this ROY covers or touches the object we want to analyze, and here as well. Next step is chart options. Currently, we have not many chart options available. This is something we will improve in future versions. It's only possible to plot one parameter right now. For example, the index average, if we are analyzing an index, or the leaf area. I will simply go for the leaf area right now, but you are free to choose whatever you like. And then last but not least, this is the possibility to check all your settings in combination and see the results, get a preview. So we have all the settings. We can analyze an index. Let's, I don't know, analyze the normalized difference vegetation index and analyze shape. We can also create an ROY overlay, but this works different from the previous windows. This actually does create an ROY overlay in the final images. But I think we leave it like it is, and we now can press on create preview, and it will create a preview of the images, how they will look once they get out of the analysis, right? So this is actually running the analysis script on your sample images. And from what I can see right here, this actually looks quite good. It got the outlines perfectly here as well. So I think this is fine. And this was the last step. Now you can see ready to run using script, base script.py, and we can press on play and let the script run. It will show you the preview images of each image it analyzes. And what we can also do is we can look at the chart, and the chart will also grow over time. You can also jump around. So this was the last image, and now also the chart got interactive. And before that, it's not interactive, but if the analysis finished, you can, for example, check out different data points. You can also zoom in and scale it back to what it was before. But you can also access all the results in the results folder. You can simply press this button and it will automatically open the results folder for you. It contains all the processed images. Those are all pseudo RGBs and with the markings you set. So for example, here it has the outline. Let's open it. Here we go. It's for documentation. You have the chart. This will open the chart for you in a browser. And you can do the same as you could do it in the analytics application also afterwards. So you don't need to keep this open. And here you have the results as DSV format. That's why I will open it in the Notepad, because it looks much nicer there than it does in Excel. But you probably know how to open your DSV files. It basically contains all the information you need: the camera, experiment ID, image timestamp, image, ROY, parameter, width, height, area. So those are the parameters you got from the size analysis, as well as the index, the mean of the index, and the median, as well as the standard deviation. It's important to say that that's the mean over all the pixels, right? So it takes the mean over all the pixels that are analyzed from the object and gives you the result right here. Last but not least, we also have a session file, the session.json file, which contains all the settings. It's not meant to be readable by humans. You can always use this to reproduce your analyses, but it also contains important information for debugging, for example, and it's simply good to keep this with your analysis results for documentation reasons. Well, that's it. You got your sample images analyzed. If you have any questions, let me know, leave us comments. So this was the quick introduction into analyzing multispectral images with RAYN Vision System Analytics.